Okay, the glorious binomial theorem. So it's x plus y to the n power is the summation of k equals 0 to the n of n choose k, x to the n minus k, y to the k. What? What is the binomial theorem? So really, the binomial theorem, what is a binomial? We've been working with binomials. Binomial is a polynomial with two terms. So, Michael Scott says, but what does it mean? So the binomial theorem is a way of expanding polynomials. We were doing this last class period. So we have x plus 3 to the 4th power, or 3 minus x to the 5th power, or 2y minus 7 to the 3rd power. It's a way of expanding binomials. Now the formula, we're not going to work with the formula. We're going to do it a little bit differently. Okay? It's good to know the formula and to see the formula, but if you go into a stats class or something, you'll probably talk about it more. Well, that might be a lie. I don't know if you talk about it in stats. Anyways, so, sorry. We did this when we were multiplying binomials. So if you remember back to the last video, this is just a screenshot from the last video, but we were multiplying out these binomials, right? Well, so let's detour a little bit. We're not in math class anymore. No, we're now in a history class. So Blaise Pascal, he is the one that is credited for Pascal's triangle. I think it's Blaise. It could be like blase, like he might be fancy. Fun facts about him. He became severely ill in childhood, supposedly due to witchcraft. Fascinating. He was educated by his father and never attended any school or university. He was a child prodigy. He's very smart. He discovered Pascal's theorem at the age of 6. Pascal's theorem has to do with like triangles or something. He invented the world's first fully functioning mechanical calculator at the age of 19. Like he's crazy. When I was 19, I was just in college chilling, you know, like I wasn't inventing calculators, but it's fine. He became a follower of Jansenism in 1642. Not sure what it is, probably a religion. He founded the theory of probability while solving gambling problems with his friends. He's a very interesting dude. He left his scientific pursuits after his second conversion. He wrote influential theological works, Letters Provinciales and Pensis. I don't know what that means. He suffered from mental illness through most of his adult life. So even though he's like this super brilliant guy, he also struggled. So he is also human like the rest of us. Fascinating. This is Pascal's triangle. And if you take a second to look at this, there's crazy patterns here. We have all these ones that go along the outsides. We have, let's see, like 1, 2, if you count down this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 blah. There's other patterns in here. So if we went down, let's see, I don't know. I'll go through the patterns in a second, but there's tons and tons of patterns. So, want to hear spoiler? Spoiler. Well, I said that weird word. That word, weird. I'm really struggling. Pascal wasn't the first to discover the triangle. So the staircase in Mount Meru, that's a picture of Mount Meru. Isn't that like the coolest thing ever? It's like a portal or something. But that's the staircase in Mount Meru. They used Pascal's triangle. Khayyam's triangle in China. Yang Hui's triangle. So there are a lot. I think there's more than that. I'm sure if you like really delve into this history. And these people were all before Pascal's time. So Pascal is just credited with this, but there were many other cultures who were also discovering this at the same time. Okay? It's kind of interesting. And it's when you dive into the history of anything really, you need to look at other perspectives of it. And that's what this is kind of trying to do. Let's build this triangle. So say you just start with a bunch of zeros and then you come to a 1 right in the middle, and then you have a bunch of zeros following forever. So what we're going to do is we're going to add the two numbers above. So we're going to like take these two numbers, add them together. You're going to get 0. These two numbers, you get 0. These two numbers, you get 0. These two numbers, you get 0. These two, you end up getting a 1. These two, you end up getting a 1, 0, 0, 0, 0. So then we end up with this. And then we can do the same thing. So we have all these zeros, but 0 plus 1 is 1. 1 plus 1 is 2. And 1 plus 0 is 1. And then 0 is forever. And then this just keeps going. So 0 plus 1 is 1. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 0 is 1. And so on and so on and so on. So 0 plus 1 is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 0 is 1. And it keeps going. So this right here, that is the triangle. Okay, and we can call it Pascal's. We can call it Yang-Huey's. We can call it Khayyam. Whatever you want to call this triangle, call it that. So here is a bigger picture of this triangle. Okay, and let's look at some patterns here. So each number is the sum of the two numbers above it. We already knew that. We were just figuring that out. So like this right here, these green ones, 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 6 is 10. 10 plus 5 is 15. And so on and so on. Pretty cool. So then the other one I showed you is those are the counting numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's going to keep going like that. We also have even and odd numbers, and they come in this weird pattern. So it's like even, and then those odd ones, and then even, and this is just going to continue. If you built out this whole triangle, you would probably see a really, really cool pattern emerge. All of the rows total to powers of 2. So that first row is that sums up to be 1. Second row, 1 plus 1 is 2, which is 2 to the first power. 1 plus 2 plus 1 is 4, which is 2 to the second. That should have been a 4 right here, not a 2. Freaking internet messing up. 3 plus 3 is 6, plus 1 plus 1 is 8, which is 2 to the third power. And that just keeps going. Blah, blah, blah. Get on with it, right, Lexi? I mean, Miss Gagan. Sorry. Do not ever call me Lexi, please. And then we have triangular numbers also. So, pretty cool. And so many more. If you want to search in like patterns in Pascal's triangle on YouTube, you're in for a journey. So simplifying the binomial theorem. So how does this relate to the binomial theorem? Well, let's look at this. So if we have x plus y to the 0 power, that must be 1. That makes me so uncomfortable. You must be an expression raised to the 0 power because, baby, you're number 1. Anything raised to the 0 power is 1. X plus y to the first power is x plus y. X plus y squared is x squared plus 2xy plus y squared. And just trust me on these. But, oh, sorry, I got ahead of myself. So this right here, so we have 1x and 1y. Notice we have 1 and 1 right there. Here we have 1, 2, 1. Well, that's right there. Okay, as our leading coefficients, because 1, 1, 2, 1. Interesting. Okay, so anyone have a guess what the next one would be? Well, I bet it's 1, 3, 3, 1. And the next one? Well, I bet it's 1, 4, 6, 4, 1. And then notice here what's happening to our exponents. Well, the first exponent here, our x, is getting raised to the 4th power, and then it counts down by 1. So 4, 3, 2, 1, and then it's gone. Then the y is starting at the 4th power, but it's counting backwards. Or it ends at the 4th power and counts backwards. Gone. Okay, and then the coefficients are the 1, 4, 6, 4, 1. Interesting. So the next one would be 1, 5, 10, 10, 5, 1. So Pascal's triangle happens to be the leading coefficients in the binomial theorem. Pretty cool. Okay, now it's your turn. Let's have some fun. So x plus y to the 7th power. So the way that we're going to do this is I'm going to do it with boxes. I really like boxes. So if it's the 7th power, that means we're going to have 8 boxes. always one more than the power. So we have these 8 boxes here. Okay, and we're going to have the first row be filled with Pascal's number. So since this is to the 7th, I need to go down to the 7th row. Okay, and that's the row with 7 as the second number. So it's that row right there. This first row is technically called the 0 row, just because it's just up there. So we call that the 0 row, and then first, second, third, fourth. Okay, so then we're going to put those numbers in: 1, 7, 21, 35, 35, 21, 7, and 1. Then this next row, I'm going to fill with the first term and put them in parentheses. So I'm going to just put x, 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 x. And then we're going to start the exponent starting at whatever the exponent was. So since it's 7, we're going to start at 7 and count down. So 7, 6, 5, 4, 3, 2, 1, 0. And then we can look at the third row, and that's going to be the second term in the parentheses. So those are all going to be y's. And then this is going to start from 0, and it's going to count up. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7. And I want you to notice something right here. 7 plus 0 is 7. 6 plus 1 is 7. 5 plus 4 is 7. 3 plus 4 is 7. 3 plus 4 is 7. 2 plus 5 is 7. 1 plus 6 is 7. 0 plus 7 is 7. So those exponents will always add up to this one. Now, anything to the 0 power equals 1, so we can just cancel those ones out. Okay, and then we are going to multiply down these rows. So we're multiplying this way. And I'm going to just write this out. So this first one, we have 1 times x to the 7th is x to the 7th. This one, we have 7 times x to the 6th times y to the 1st, which is just y. This one, we have 21 times x to the 5th times y squared. 35 x to the 4th, y cubed. 35 x cubed, y to the 4th. 21 x squared, y to the 5th. 7x y to the 6th, and 1 times y to the 7th, which is just y to the 6th. Okay, and there's all those numbers that we just talked about. Now, between each of these, we need a plus sign. So I'm just going to put these giant addition signs between them. And then you can just pull everything out of the box. So our final answer is x to the 7th plus 7x to the 6th y plus 21x to the 5th y squared plus 35x to the 4th y to the 3rd plus 35x cubed y to the 4th plus 21x squared y to the 5th plus 7xy to the 6th plus y to the 7th. Okay, let's do one more. So here we have, whoops, I'm getting ahead of myself. So this is 2x minus 3 to the 5th power. Well, since it's to the 5th power, we're going to have 6 boxes. It's always one more than the power. And in that first row, that's where we're going to put Pascal's numbers. So we go down to the 5th row, which is that one, 1, 5, 10, 10, 5, 1. And we can double check because it has 6 numbers, which means it must be right. So there's those numbers. Now, the first term goes in the second row. So that 2x, and put it in parentheses, please, please, please. And then the exponents start high and end low. So it starts at 5, and then 4, 3, 2, 1, and 0. The next row is negative 3, and it starts low and ends high, so it's 0, 1, 2, 3, 4, 5. Now, anything to the 0 power cancels. And then I can just multiply down. Now, one thing I maybe want to do right here, let's see if I did do it. I didn't. Okay, so we have 1 times 2x to the 5th. Well, what the heck is 2x to the 5th? Okay, well, that's going to be 2x 5 times. Okay, so that means it's 2 times 2 times 2 times 2 times 2, which is 2 to the 5th. And then x to the 5th. Well, 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's where I'm going to get 32x to the 5th. Okay, so this right here is actually 32x to the 5th. This one would be 2 to the 4th, x to the 4th. Well, 2 to the 4th is 16, so this is actually going to be 16x to the 4th. 2 cubed is 8, so this is 8x cubed. 2x squared is 4x squared. And 2x to the first is just 2x. Okay, we can do a similar thing with our negative 3's. So negative 3 to the first power is just negative 3. Negative 3 squared is the same as negative 3 times negative 3, which is going to be negative, or not negative 9, positive 9. Well, then positive 9, let's just multiply it by negative 3. That's going to be negative 27. Negative 27 times 3 is 81. And 81 times negative 3 is negative 243. So we can simplify these a little bit in their boxes. And a lot of times it's just a calculator. Just use a calculator, okay? So then this is going to be 1 times 32x to the 5th. This is going to be 5 times 16x to the 4th times negative 3. This is 10 times 8x cubed times 9. 10 times 4x squared times negative 27. 5 times 2x times 81. And 1 times negative 243. And I think we should simplify these just a little bit more. Multiply the numbers together. So 1 times 32 is 32x to the 5th. 5 times 16 times negative 3 is negative 240x to the 4th. Just use your calculator. 10 times 8 times 9 is 720x cubed. 10 times 4 times negative 27 is negative 1080x squared. 5 times 2 times 81 is 810x. And 1 times negative 243 is negative 243. Put those big plus signs between there. And we get 35x to the 5th plus negative 240x to the 4th plus 720x cubed plus negative 1080x squared plus 810x plus negative 243. Now, when you add a negative, it's really the same as subtraction, so all of those can just become subtractions. Okay, notice the alternating pattern between signs. This will always happen whenever you're subtracting. Okay, all done. You can relax now. All right, we'll go through this a little bit more tomorrow, but hopefully you took good notes. Okay, bye. Have a good day.